All right, so after you watch the other Jacob Clifford video, this is me practicing what he did at a little bit slower pace. He just teaches it a little bit faster. And like my little like instruction sheet is what you see in front of you. So basically I'm going to go through like how you should complete these problems. And then I'm going to start one. And I'm going to do like the top half of the chart. And then I'll have you guys do the bottom half of the chart in a Google form, essentially. Okay. So the first thing we have to do is do the output other goes over, or input other goes under to find the per unit opportunity cost, to find the comparative advantage, who is making what, who wants what. So here is my problem. I'm going to zoom in here. It says, using equal amount of resources, the U.S. and Mexico produce the number of cars and planes in the chart below. So that's telling me how much they're producing. This is an output. So output other goes over is going to be the method that we are using to find the per unit opportunity cost. So quickly, I'm just going to go write this into the chart. U.S. can make 10 cars or 5 planes. Well, what if they make 1 car? How many planes does that cost? What if they make 1 plane? How many cars can they not make? Same for Mexico. If they make 1 car, how many planes can they not make? If they make 1 plane, sorry about that, how many cars can they not make? So here's what the U.S. can make in cars. If they don't make planes, here's what they can make in planes. If they don't make cars, same for Mexico, can make 12 cars or 3 planes or some combination. But what if they just make 1? We need to find the per unit opportunity cost. Now remember, we're using the OOO, output other goes over. So I'm going to take this number 5 and I'm going to put it on top. It's going to go over the number in the box for cars, which is 10. 5 over 10 simplified is 1/2, meaning that in the United States, making 1 car is the same time, energy, and resources as making half of a plane. Then we're going to go the other way, and I'll switch colors for you. I'm going to take my output number and put it over here. So it's going to be on top, 10 over 5. 10 over 5 is 2, and you can tell that they are reciprocals. 5 over 10, 10 over 5, 1 over 2, 2 over 1. They're reciprocals of each other. They're opposites. Let me do Mexico real quick. I'll go super fast. Output other goes over. So the 3 goes on top of the 12. 3 over 12 is the same as saying 1/4. And then for this one, output other goes over top. So the 12 goes on top. The 3 goes on the bottom. 12 divided by 3 is 4. So in Mexico, making 1 car is the same energy and resources as making 1/4 of a plane. Making 1 plane is the same energy and resources as making 4 cars. So now we're going to get into the new stuff today, and this is terms of trade. And it is much harder. And I'm not going to lie to you, I had difficulty learning this when I was a student, and I had difficulty relearning it when I was out of college and I had to start teaching economics. So this is a skill that takes lots and lots of practice and correction in order to get. And I'm going to be honest with you, what you see here, kind of like you saw in the Jacob Clifford video, you're not going to see this as a free response on the AP exam. The most you'll get is a question, like a multiple choice question, which we might do one in class. That's basically, or maybe I'll show you one here in a second, that will say like, would 1 car for 12 phones be an acceptable terms of trade? And you would have to do all this math to figure out that one thing. They're kind of multiple choice questions that some teachers would advise that you skip and come back to at the end if you have time, because of the sheer amount of work it takes to get the answer. Or it could be like an add-on to a free response where they have this big PPC of 2 countries. They ask you who has the comparative advantage, the absolute advantage. They ask you what would acceptable terms of trade be, and then they might throw on the end, would 1 car for 2 planes be acceptable for Mexico and the U.S.? And it would be 1 question, like 1 row of this instead of 10 different rows or 7 different rows. So just keep that in mind. This isn't going to be heavily tested. It'll be a one-off, 1 or 2 questions on the end of a multiple choice or free response. So let's dive in. So we have done, if I have this little checklist for you guys, which this note slide is posted on Google Classroom, we have done this. We've done the OOO or IOU method. We write out who wants what and only focus on those numbers. Well, what we haven't done is figured out who has comparative advantage and absolute advantage. So absolute advantage is not required to answer these questions, but let's just review. Absolute advantage in my little book requires absolutely no math. So before we did all this funky math, the OOO method, if you just look at the chart, who should make cars? U.S. can make 10, Mexico can make 12. Okay, 12 is greater than 10, Mexico. if we just look at the chart, who should make planes? Okay, U.S. can make 5, Mexico can make 3. There you go. That's absolute advantage, no math required. Comparative advantage is where we find the per unit opportunity cost using the OOO or IOU method and figure out who has a smaller opportunity cost for making that good. Who's going to suffer the less if they make that good, and they should specialize in that good and trade for what they are not making. So let's take a look at how much time, energy, and resources it takes to make one car in each of these countries. In the U.S., it takes the equivalent of making one car is losing out on half a plane, whereas in Mexico is losing out on a fourth of a plane. So it looks like Mexico should focus on making the cars because they are better at it. What about planes? In the U.S., making one plane is the equivalent of making 2 cars, whereas in Mexico, they would lose out on 4. So 2 is less than 4. So we want that to be what they do. So it looks like the U.S. is going to make planes and Mexico is going to make cars. So that means that they need to trade for what they don't have. So I'm going to go over here and I'm going to remind myself. The U.S. has a comparative advantage. I'm going to write comparative advantage, in planes. So they want to trade for cars. Whereas the Mexico has the comparative advantage in cars, and they want to trade So Mexico has the comparative advantage in cars, and they need to import planes. So that is going to be very important, and we're going to focus on what I'm going to highlight in green. What they want is what we're going to focus on. So when we're finding comparative advantage, we circle on like, okay, who has the lowest opportunity cost? We're now kind of going to ignore those boxes. We're not going to pretend that they're not even there. And we're going to focus on what they are importing, which is here, okay? So when we are focusing on what they are importing, we have like set terms of trade here. And like in the little Jacob Clifford video that you watched and in my little tips and tricks here, we've written out who wants what. And we're going to take each proposed term of trade and flip it. So right now it says 1 plane for 3 cars. Okay, well, what about 1 car for how many planes? And it's going to be the opposite, 1/3. Of a plane. So I'm going to go ahead and do that for all these real quick. 1 plane for 6 cars would be 1 car for 1/6 of a plane. This one's going to be mean. I'll show you how to do that in a second. This one is going to be 1 car for 1/10 of a plane, which would be 1 plane for the opposite of that, which would be 10 cars. Okay. And I should write 4 here so that it makes sense. All right, now we encounter this one, and this is a butt face move of the maker of this worksheet, and also AP if they were to ever ask you to do this, which I don't think they would do. We've been working with per unit opportunity cost, per unit meaning 1, and now they throw us a 5 and then throw us a 3. Like, that is so incredibly rude. So we know that 5 cars is the same as making 3 planes. So you could probably figure out that it's going to be 3/5 and 5/3, but maybe you can't figure that out. You're not like a super mathy person. How would we figure out what 1 car costs? Well, we've done this before. This is basically like as if we had this comparative advantage chart and we just have to do an output question. 5 cars is equal to 3 planes. Well, what about 1 car? We would take this and we would go over. Output, over, output, other goes over. So 3/5 would be for 3/5 of a plane. Okay? And then, so what would the opposite be? If we make 1 plane, it would go the opposite direction. Output, other goes over. So it would be for, just can't win today, for 5/3 or 1 2/3 of a, what was I thinking? Car. Okay. Another way of looking at that, you could do this. If 3 planes is equal to 5 cars, then what is 1 plane equal to? And you could fill out X, and you get 3X, then you get 5, and we divide by X, we divide by X, divide by 3, and we would get 5/3, which is what we got here. And so that would be 1 2/3. Okay. All right, we're moving forward now. That's just another way of doing it. Okay, and they're going to do that to you here in a second, and I'm going to help you out because it's incredibly rude, and I hate that they do that to you. But here we go. So here's how we go about this now. We focus on what they want. So if we are looking, we're going to do the U.S. column, and then we'll bounce over to Mexico. Then we'll do U.S., and then we'll do Mexico. So if the terms of trade, the countries come together and discuss, can we trade one plane for 3 cars, which is the same as saying 1 car for 1/3 of a plane. The U.S. would say, well, we want cars. And if we produce cars, and we're ignoring the ones that we have circled, we're ignoring the comparative advantage, we're only focusing on what they want, what they are importing. If we produce our own cars, it costs us half of a plane. And you want to trade 1 car for 1/3 of a plane? Well, that sounds pretty good to me because I'm losing out on less. So this would be a yes, because the 1/3 of a plane that they have to give up is less than the 1/2, and we're still looking for less than numbers. Okay, let's go to Mexico. Mexico, we're going to ignore what they're making. We're going to focus on what they want. They want planes. If they produce 1 plane in Mexico, it's the same energy and resources it would take to make 4 cars. And the proposed trade is 1 plane for 3 cars. Well, 3 is less than 4, so sounds like a heck of a deal. There we go. They are fine with that one. Okay, moving forward, let's go to the next one. When we are looking at 1 plane for 6 cars, we're going to go to the United States, and we're going to focus entirely on cars because the United States is planning on importing these cars. So we have to focus on what can they make car-wise? 1 car is equal to 1/2 of a plane. Should they trade 1 car for 1/6 of a plane? Yeah, because that is less than what it would cost them to make it. So yes. Okay, let's go to Mexico. Mexico wants planes. So we're focusing on planes. If they make a plane, it costs them the same as making 4 cars. If they trade for a plane, it's like giving up 6 cars. They don't want to give up 6 cars. They'd rather just give up 4 and make them themselves. So this is a no. This is a not acceptable terms of trade. Okay, let's move forward. When we move forward, 5 cars for 3 planes. Again, we kind of swapped it, made it easier, made it per unit. We go to U.S. U.S. wants cars. They can make 1 car, and then they lose out on the opportunity to make half a plane. Or they can trade for 1 car and lose out on the opportunity to make 3/5 of a plane. And this is where you might have to get your little calculator out or imagine a pie graph. 3/5 is going to be more than 1/2. And they want to go with the lowest opportunity cost. So this is going to be a no for them. Okay, so let's go to Mexico. Mexico wants planes. So if they make a plane, then it costs them the same time to make 4 cars. What if they trade for a plane? 1 plane for 1 2/3 of a car. Sounds like a good deal. That's less than the 4 they would have lost out on. That one's a yes. Okay, let's move forward and do 1 more here before I drop you some hints. In the United States, they want cars, so we're going to focus on cars. They can make 1 car, and it costs them the same amount of time as it would to make half of a plane. Or they could trade 1 car for giving up 1/10 of a plane. 1/10 sounds better, so I'm going to say yes to this because it was the lower number. We're always comparing it to this. And if this number is lower, it's a yes. If this number is higher, it's a no. And we're about to get a no here in 1 second. So we're going to go to Mexico. Mexico wants planes. If they make planes, we're ignoring what they're making. If they make what they're not good at, if they make what they meant to import, 1 plane is equal to the time, energy, and resources of making 4 cars. But this proposed plan is saying, we'll trade you 1 plane for 10 cars. But that means I'm giving up more cars than if I just made them myself, where I would just give up 4. So this one is a no, and here's the reason why. What they want, planes, they could make at the cost of 4 cars or trade at the cost of 10 cars. And we don't want our costs to be high. We want our opportunity costs to be low, okay? All right, so that's essentially what you're going to see. I'm going to drop some hints down here, and then you're going to have multiple choice Google form telling me whether these are yes, no, yes, no. And then when you hit next on the Google form, it's going to have a comparative advantage practice. Oh, let me actually pause. Let me explain one more thing to you. So the very last thing on the Jacob Clifford video that you watched was about acceptable terms of trade, which is more commonly what they will ask. Acceptable terms of trade means what would be beneficial to both parties. And this is so simple. I love when they ask it on the AP exam because you've already done the math. Here's what you would do. And I'm going to erase all this crazy stuff that I got going on here. Let me just like, okay. Here's what we're going to do. We are going to focus on these comparative advantage numbers. And we're going to decide what would both countries agree to trading one car for what? It has to be less than and more than something. So here is what we would do. We would take the biggest number, which is right here, 1/2, and put it out to the right. And the U.S. isn't going to want those cars for any more than that. Whereas in Mexico, they are making the cars, and they're not going to want to trade for any less than 1/4. So we need to find a number within those bounds. 1/2 is greater than some number here, which is greater than some number here. So 1/3 would fit in there. You could put like literally any number in there that fits. This is 0.5, this is 0.25, we could say 0.3, we could say 0.48. Any of those would be acceptable terms of trade because it's within the lessened opportunity cost and the bounds of making it for each country or trading for it. We're going to do the same over here. Now, in this example, remember that the U.S. was making planes, and so they don't want to trade for any less than 2 planes. But Mexico wants planes. They don't want to trade for any more than 4. So 4 is less than something, which is less than 2. So what would be an acceptable number in here? 2.5, 3.75, 3. Just keep it super simple. Whatever fits within there would be favorable terms of trade. Okay, so let me give you hints for this bottom part. They really screwed you over on this bottom part, where they aren't saying per unit, 1 plane for blank cars, 1 plane, 1 car for blank planes. And they really handed it to you. So remember, this is the same as the OOO, output other goes over method. So if I want to find 1 car for how many, or 1 plane for how many, I would just do the other goes over. 3 over 10 would be 3/10. 10 over 3 would be 3 1/3. 3 1/3. This would be 1 car for planes. This would be for cars. Okay, so that's how to make it easier. Let's say that completely confused you, the OOO thing. You could just say 10 cars for 3 planes. Well, what is 1 car? Then and fill in x, and you get 10x is equal to 1 times 3 divided by 10 divided by 10, and all of a sudden we have the same answer that we got right here. See how I did that? I'll do the other one real quick, and then I'm going to drop you probably one more hint and leave you to flounder on the next one. Okay, so if I were doing this bottom one, let me do the next one. So 1/2 a plane for 10 cars. I'll show you the 2 methods. You can go OOO. So just take this. What is 1 plane then? For how many cars? And what is 1 car for how many planes? Sorry about my handwriting. I'm trying to fit it into a very small space. I would do output other goes over. So 10 over 0.5. Oh my gosh. My pen is dying again. I am so sorry, my friends. Hold on. Give me 1 second. Okay, thank you. Sorry. So 10 over 0.5 is 20. I got lost there for a second. 1 plane, 10 over 0.5, which would be 20. Or you can flip it the opposite. 1 car for, I would do 0.5 over 10, which is 0.05. Oh, that's terrible. I hate that. You know what? Miss Keller call. We ain't doing it. Cross out number 8, my friends. We're not doing it. And I'm going to take it out of the Google form. And I'm going to leave you to flounder on the last one. I hate that they did that to you. That was really rude. I did not like that. Okay, so we're crossing that one out. And so I did 1 through 6 for you. You're going to do 7, 9, and 10. I'm going to take out 8 entirely because it is extremely rude. And then you're going to do a practice comparative advantage. All right, thanks, kids.